Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to another episode of Interviews with My Research Heroes. In this episode, I interview Sara Hooker, who's a research scholar at Google Brain. Sara has this amazing background and a non-traditional path into research. If I may, we of course talk all about her journey into research, into machine learning broadly speaking. Sara is still very much connected to her roots. She's from Africa and she shares her amazing perspective on how different problems, different constraints can contribute to the field, research or otherwise, in interesting ways, which was one of the really unique perspectives on this series. We also delve into many rich advices on how you should approach the field, how you should make the transition. Sara shares her journey, but I believe her journey is really a proxy to anyone who's willing to put in the hard work. And she shares a very amazing, transparent overview of on how her approach has shaped her journey over the years. We also dive briefly into her research interests towards the end and discuss one of her recent works. We talk about a lot of things which might not have been discussed in depth. So please check out the show notes if you'd like to explore that. I mentioned this in the interview as well, but Sara really has been a role model for me, as I'm sure she has been for the complete community. And it was really an honor to host this interview. Her perspective on all of the questions was really interesting to dive into. And with that, and without continuing about how much I enjoyed this interview, without further ado, here's the conversation. Please enjoy the show. Hi everyone, I am honored to be talking to one of my role models about whom I learned through the FastAI community, Sara Hooker. Sara, thank you so much for joining me on the podcast.
Thank you. It's so lovely to be here.
I really have a lot of, I ask a lot of stupid questions, so I have a long list that I can't wait to ask you. I want to start by talking about your journey. You followed a non-traditional route into machine learning research, if I may. Do you think your economics background gave you an interesting perspective for research?
So it's interesting. I guess there's a few questions in there. So I did follow a non-traditional background. Economics was part of it. Like originally I dreamt of being an economist. So in some ways my segue to machine learning was accidental because I was so intent on becoming an economist for the World Bank. And then I moved to the Bay Area to work in economic consulting, which is doing statistical analysis for these economic problems. And then when I was in the Bay, I started to be exposed to a lot of different machine learning problems. I was working with engineers and with researchers, and it was almost like it clicked overnight. This was a much more exciting way of modeling complex real-world data. So that being said, I still think that a lot of the perspectives that economics gives you are really interesting. Like economics have a strong emphasis on kind of justifying additional complexity. So a lot of economists, their goal is to communicate to policymakers what factors influence large-scale aggregate trends in data. And so a lot of the emphasis is on how do we justify the assumptions we have about data distribution, how do we leverage small data samples where data is scarce, and also causal framework. So a big emphasis in economics is in understanding the but-for world. If this did not happen, what is the outcome of the separate scenario. And that's actually kind of undergoing a popular wave in deep learning. It's a very tricky type of deep learning because in order to do it effectively, the best way is you conduct a random experiment, which economists are very, very fond of. And that's harder to do in the deep neural network setting if you have images. It's hard to like remove pixels and say this is a but-for world. So there's many interesting topics and lenses that economics lends. But I would also say that it's as much being a factor. You started this by saying, I'm going to ask you a series of stupid questions. I asked a lot of stupid questions. And I found that by doing that, like I gradually just got better and better answers. And so I think a lot of it is, yes, the economics background helped, but so did just my passion for the subject. Really was so willing to ask stupid questions, for so it became slightly less stupid questions, which is perhaps what really helped.
Even the process as you described it sounds much like how an author would narrate their paper, honestly, if you're just reading an archive paper.
That's funny. I mean, I guess it's perhaps because it happened over such a long period of time. So it sounds like a story almost. But yeah, hopefully that sounded sensible at least. Saying it sounds like a paper makes it sound like it was a little bit sensible.
So to give a plug to your article, it's called Slow Learning. It'll be there in the show notes. But in your article titled Slow Learning, where you shared your journey into the field, I'd love to ask you, what advice would you give yourself if you were starting your journey in 2020?
Yeah, so the article that you mentioned, which is really about how sometimes when we attribute success to someone, it's not really about that single moment. It's about a series of moments that finally leads to something that people then associate with that person.
The
And in
dots
my
always
case,
connect looking backwards.
yes, precisely. So we always think of someone's success as the last thing that they did that was very successful. But in fact, that article is just about how so much is a cumulative effort, and it's about a cumulative sequence of just pushing forward through failure. And in particular, I thought it was so lovely to come onto this podcast because you've been so honest and candid about your own failures along the way. And I think for anyone who's teaching themselves, failure is so much part of the day-to-day, and it can feel so lonely that it's important to be honest about how long it takes and how difficult it is. Because it's important that if people feel like it's taking a really long time, that's because it takes a really long time, not because it's them. And so my article, So Learning, was really about, I started off really passionately wanting to be an economist. And then when I started connecting to these problems, particularly in the nonprofit area that required more complex modeling, what I did was, screen has gone blank. Okay, I'm back. But what I did was I wanted to explore more complex forms of modeling. And so I really wanted to grapple with two things, both foraying into more machine learning, but also becoming more adept at end-to-end technical skills. And that whole article is about really the difficulty of that. So I didn't do computer science as an undergrad. I pursued it post-undergrad. And I took perhaps a brute force approach where I just decided that the way to do this was to work on applied projects and to build my skill by focusing on the impact I wanted to have. And then that culminated in eventually teaching machine learning and then joining the AI residency program and then joining Google Brain. But the space between that was a very long period of time. And so that was the whole intent of that article. And I guess that leads to your question, which is, what would I tell myself at the beginning? And to be honest, I don't know if I would. And the reason why I say that is that to communicate how much effort it took in hindsight, I think my former self would have been deterred completely. I think often at the beginning, all that keeps us going is the sheer passion for the subject. Without regard for an understanding of how long it will take to reach a degree of expertise. What I tell people now who are starting, who are not me, I say focus. I say there's a lot of materials, and I think that the most important criteria is to choose a project and just start working on a project, because otherwise the world looks too big. There's too many options to pursue. And in fact, if you're working on an applied project, you'll learn theory in the progress, because you'll have to make decisions about the tools you use and the packages you use. And it's much more sane. It allows you to measure progress, and it allows you to not take on too much. And frankly, work on a project with people who are better than you. That's like the second most crucial criteria in making progress, is that if you're the best in your project, then you're not going to be going very quickly, because humans are still very social people. We do our best when we're held accountable by those around us, and when we respect those who work with us, and we want to do our best for them. So I think it's really important to always be perhaps the worst in your group, so to speak. At least at the beginning of your career, you should be working with people who are far better than you, have something to teach you. And then the final thing is that there is a brute force period. Like, there's no getting around that. And I think that partly figure out if this is something that you want. And the way to figure that out is by having conversations with people. The truth is, the reason why I wouldn't tell my former self precisely how much effort it takes is because in any one instance, it can feel overwhelming unless you feel like you're going through it, unless you feel like you have an end goal. And my end goal was always that I loved doing what I was doing. And for me, it just felt like I knew it wasn't necessarily Google. Like, I feel like I could be equally happy just doing this in some other area, thinking about machine learning problems, like working on either applied or on research. But I knew what the end goal was, which made it easier for me. And if you're less certain about that piece, talk to people, because make sure it's what you want. Because the hardest thing is you won't make it past that painful brute force period if you don't really know why you're doing it. I don't know. How was it for you? I'm very curious, because I love this conversation, because you went through a similar self-taught journey, which is so rare. Like, normally when I do interviews, I'm doing it with people with PhDs who the whole idea of self-taught is very foreign to them. So it's lovely chatting to you, and I want to hear what your experience has been.
First, but thank you for such an transparent view of your journey. For me, I like to call myself community taught, being community taught. So like you, I didn't realize it, and I think where many people, like even my question usually takes different approaches, is we try to connect someone's journey after they've become something. After Sarah has made it to Google AI, I would try to look at her journey. Oh, this might have been helpful, which is not the case while you're going through it. So for me, it was just naively, like you mentioned, brute forcing everything that I could think of. What's Kaggle? Let me try that. Someone mentioned I should write about my journey. Let me do that. There's something called podcasting. Let me start a podcast. There's something called Fast AI. Let me try that course. There's something called this course. Let me try that. So in hindsight, I was all over the place. Now I of course wouldn't mention it because it'll like make me look bad, but it was like a brute forced approach, very, very much like yours, although in a probably much worse fashion.
Well, it sounds like you found a community, which I think is better than what I did. So I was brute force, but I was very focused on projects. Like, I would do one project at a time, but sometimes I was quite lonely, because in some ways the hardest part about being self-taught is that you're hitting things by yourself. And I found that once I started joining communities, like either through working with other people on projects, inviting them to come join me, or by things like Fast.ai, which I know you were also part of, those were hugely like just a relief, because it felt like I had been doing this journey by myself. And then finally, I felt like there were other people who were equally passionate. And we often forget how important communities are when you're learning something new, because it takes so long when you're trying to figure out things by yourself. You get stuck on an error, and perhaps that kind of bubbles into days of frustration. But when you're with other people, the learning cycle is much more quick. Like, even when I eventually joined Google, I think the biggest shock to my system was how quickly my iterations of learning sped up because there were people with insight to unblock me a lot quicker. Particularly, I think that's the case with something which is as specialized as deep learning, where a lot of the research is almost developing before our eyes. There's not like a body of knowledge that you can consult for particular areas.
I mean, from my perspective, if I look back, the most important thing for me was I was in my undergrad while I was doing this, and I tend to disagree with people who would say that computer science really helps. To me, I still felt very underqualified. So what I would do is, even though I was slightly ahead of my peers, which tends to make undergrads pretty proud, that wasn't the case. I would honestly reach out to people just on the internet. And tell them, hey, I'm interested in this topic. I want to build something. Could you help me? Could you give me some perspective? And just that series of contacting so many different people over all of these communities. So that's where my phrase being online taught, being community taught comes from, because it's not one mentor, one particular mentor, but it's this complete online machine learning community, the Twitter ML community. I proudly sometimes say that, hey, my blog posts have gotten over 1 million views, but it's the community which has even bothered retweeting it or just sharing it across to their own peers. So that's why the community, to me at least, matters a lot.
Bravo. I feel like that's fantastic. And also, it's something I always recommend to people who are starting out is that very important people will open your email. It's kind of shocking. It's like this hidden like gift or superpower that you don't know you have. But if you write a well-motivated email, a sincere, authentic email, people will open it and they'll reply. And I always say something that people don't know is that researchers at places like Google, they often do external collaborations. They often are willing to mentor people outside. And so sending a well thought out email that is motivated, that shows that you've read that researcher's work, that shows that you're passionate and that's authentic to you, it often goes a long way. Like, although you think researchers are these people who may be too busy, but in fact, researchers don't get that many emails. They're probably pretty excited to like get an email from someone who's sincere and who wants to do something in their community for the better. So I would recommend that I tell everyone, especially even when I go and tutor at different machine learning schools, I always say it's really important to have the courage to just send emails to people that you admire. If you read a paper that you like, send an email saying why. If you read a paper that you don't like, send an email saying why. That's the other funny thing about researchers. If you're grumpy about their work, they'll be even more invested. They'll be even more like, oh, that's so interesting. What did they find that? And they'll reply immediately. And people respect like just having the articulation to reach out. So early on that was something that you could do.
To add to that, now I think counting the unreleased interviews, it's close to 120. All of these are mostly through cold contacting people like you, which still surprises me to this day. So please do reach out to people for mentorship. So I also want to talk about how you shared this in your write-up as well. You learned coding, or you improved your coding skills by waking up early, spending a lot of hours. Did you do a lot of competitive programming? Was it a lot of implementing papers? What would be your advice in hindsight? What's the best way to do that?
Yeah, so that's a very good question. So as I mentioned, I didn't do CS undergrad. And in fact, what I did was a lot of programming that was related to economic modeling. So economists tend to use things like stata, R sometimes, and these are like statistical modeling programs more than end-to-end development programs.
Are you
So
team
when I
Python as
joined,
well?
so before I joined the startup Udemy, I had never done Python. So this was all my economics background. And then when I decided to do ML, I joined a startup called Udemy. And that was in some ways, like that gave me a huge opportunity because I came into Udemy as a data analyst and I developed a fraud algorithm to detect like whether there were fake reviews on course pages. And it was a really interesting problem. And I developed this whole algorithm, but in fact, fact, the tricky part was that when I was done developing it, I had to hand it off to the engineers to deploy it. And that bugged me because I just felt like I felt like I wanted more end-to-end control. Like I want to be part of every part of the process. Because actually what's often interesting about deploying algorithms is that the act of deploying gives you really good feedback about how to formulate the efficiency of your algorithm and scale it. So that's when I started what you've termed and I've termed the brute force stage, which is I started getting up very early before work. I did a part-time coding a program after work. And I was really using that time for projects, because the truth is that because I was starting not from a CS background, but after my undergraduate, it was really important that I had a very focused intent. Like my goal was, if I just tried to study all of CS, I just knew that I would lose enthusiasm. So I focused it around projects that I was doing for nonprofits, and I was working on end-to-end deployment for different algorithms. One was like predicting how the difficulty of student curriculum, well, how they would take courses. The other was detecting chainsaw noises in rainforests, so using audio stream from rainforest to detect. And so I was using real-world projects to kind of really motivate and hold me accountable in terms of my goals. But even after a year doing this brute force method before work, after work, my coding skills still weren't good enough. And in fact, then I had a moment of luck. Like my director of engineering and VP of engineering, they let me transfer internally at Udemy. So now I was working within the engineering team, working within the engineering machine learning team, and that was really important. I always say to anyone who's beginning, it's really, really crucial that you move as quickly as possible to doing something full-time because the biggest accelerator is going to come when you're able to do something full-time. All the incentives are aligned. And at that point, I would say that's when it really started accelerating. I got a lot of experience in development, and in parallel, I did prepare coding interviews. But I would say, I think partly I would say that for research interviews, they're a little bit different from your typical coding interview. Perhaps you found this in New York when you
The
did
hard
your
way,
interview for
yes.
Google. I think it's tricky because I think at that point everyone is so qualified. Because I even remember my residency interview, and I came into the room, and we were all held in the same waiting room. And I came in, and they're like, people were just making chit chat, and they're like, "Where are you from?" MIT, Oxford. And then they're like, "Where are you from?" And then I'm like, "Oh, I'm actually just self-taught." And it was just, it's just, I think it's just very competitive at that stage. And I think it comes down to weird things like luck, because everyone is so qualified. But there, the format was a little different. And typically in research interviews, it's a little different. So you do coding, but you also do what is typically called your research interview part, which is where you think about a research problem, or you give a research talk, or you sketch out a solution. And even the coding is more tailored to research. So these days, questions tend to be, can you code this particular algorithm? So anyone out there who's considering like research-related roles, I definitely suggest if you focus on coding, it's not your typical coding interview. It tends to be I would definitely make sure brush up on how to code a linear regression from scratch, or how to code a clustering algorithm, because it tends to be tailored towards figuring out how can we isolate, both in the coding questions, some elements of research knowledge about different algorithms.
Absolutely. I distinctly remember, so there's a nice lunch break during the interviews, and I spoke to everyone. I went back and had like 4 or 5 ice creams because I was sure I'm never coming back to Google after talking to the other interviewees that were there.
The ice cream is so good. Did you have the soft serve ice cream?
I think yes, along with the yogurt ones. I think it might vary across
Oh,
campuses. I'm not
that
sure.
sounds lovely.
But going back, you mentioned you found these projects. How would you recommend someone to find these projects? Because many times, just undergrads, just students are stepping into machine learning, and they don't know where should they ideally apply these skill sets. Or
Yeah, I actually think that the tricky thing is that I think that we lack the confidence that we know what the problems are. And I'll make this concrete. I think that particularly international candidates think that they have to solve either a benchmark that's a US data set or a Kaggle competition. And yes, these are valid ways to practice. But I also would say that we forget that there's problems in our own communities. So I grew up in Africa. My parents met in Sudan. I grew up in Mozambique, Swaziland, Lesotho. My parents moved to Kenya and then Liberia. And for me, the main driver initially in doing projects was actually not to necessarily, it was more what followed was because of the projects I connected with, I wanted to improve my skills. But I initially started projects just wanting to help the communities that I had grown up in. So I reached out to nonprofits and I contacted nonprofits in different communities I've been present in. And I asked, can I help? Do you need data help? And it wasn't just me. I started a nonprofit that involved, at the time, when we first started 7 years ago, it was just 4 of us. But we just decided, let's reach out and let's see who needs help. And the reason why I bring this up is that I think that we tend to have a very odd US bias sometimes. Like I think we think, what are researchers using? What are the data sets that they are benchmarking against? And in fact, there are so many interesting problems that are not correlated with geographic location. In fact, like problems are everywhere. And so I would prompt people to think, what is happening in my community? Like, do the education system need help? Can I reach out to nonprofits and see what problems that they have? And this becomes a kind of self-fulfilling prophecy because, in fact, once you reach out to nonprofits, it turns out that nonprofit communities are quite close together and they'll tell other nonprofits. But we should start looking closer to home in terms of figuring out where we help and what problems we want to work on.
That's amazing insight. I also want to know more about Delta Analytics. Can you highlight the current goal of the mission and about your involvement these days in it?
Oh, yes, that's an excellent question. So Delta is the name of the nonprofit I just mentioned that I started 7 years ago with those, I guess it was 4 of us. It was me and Tom, Cecilia, Jonathan. At the time, we were all economists. And since then, it's just grown into a much bigger community. And in fact, today there's probably 200 people plus part of the community, but it's still quite small. The goal is that every year we have a data fellowship and we have a teaching fellowship. And the teaching fellowship is actually global, which means anyone can participate. And the teaching fellowship aims to make machine learning education more accessible. So it would actually be things like what you're doing, hosting this podcast and making like these ideas more accessible. But it would also be teaching in local communities. And so we choose educators all over the world that have promise and support them. The other part is the data fellows, and they work with nonprofits. And both sides work to really bridge the skill gap and also eliminate the skill gap by building technical capacity. And now I'm involved more on the education side. So I started as the founder, and then I was very relieved to have Jonathan step in a few years later, and now Takeo, and now he runs the data side, and now I get to focus on my true love, which is the teaching side, because I think that the most important thing for sustainability is that eventually we're able to teach capacity within communities themselves and have leaders there own projects end to end.
If you'd like to join or know more about this rich community, I'll of course have it linked in the show notes. But this also brings me to another interesting tangent, which is many people enjoy giving back to the community, especially the ones like us who might have learned through other communities. There's also this aspect of self-doubt that comes with, hey, I could probably teach a topic to someone, but I'm not an expert yet. I'm not experienced enough. And I think I've read in your article that even during your initial days of learning, you had taken up a few lectures. So how do you think someone should approach that tangent?
I think it's so important to teach when you learn. And this is why. So this is my pitch to those that are nervous about it, is that the people who are learning are best equipped to know what it's like to be a beginner. And often my colleagues who I love dearly, but they're too far in, they're too far gone. When you hear them talk, you kind of nod, you're like, but you can just tell they're too far in, they're too dense. They don't remember what it's like to not see it for the first time. Whereas beginners, because you know what you didn't understand, you also know why it's important to communicate. And the other thing is that beginners also tend to use language which is more accessible, which is also so important for people coming into the field. Like my lovely colleagues tend to get a bit the further in you feel, the more you use shortcut language. And this is language that is a shortcut for your colleagues because you both know the same word, but it's miserable for beginners. They're just sitting there nodding, smiling, and then at the end they walk away feeling, how am I ever going to do this? And so a lot of why I think it's so important that beginners teach is that they are really well placed to identify new questions to work on. Some of the best questions that I receive come from people who don't know what they shouldn't ask. Like when you get far enough into a subject, you end up feeling embarrassed about asking certain questions because you think, oh, maybe it's obvious, like maybe I should know this already. And beginners don't have any shame like that. Like they just ask whatever comes to their mind because they don't know what's obvious and what's not. And that's often some of the best questions because often they ask the right questions about why do we do this? Like, why are we still doing things this way? And in deep learning, there's many questions where there's no reason we do things a certain way. Like, for example, random initialization. We randomly initialize all of our networks. That's really because we have no hypothesis about a better way to do it. It's because we should do it in a better way. Like certainly recent research on lottery tickets suggests that there's really important properties to initialization that helps convergence, but we do it randomly. So there's things like this that a newcomer will just ask and put their hand up and be very confident asking, and the researcher will be like, you're right, that's a very good question. And that's again why newcomers have to teach. So that gets to the tricky part. How do you teach and how do you find the confidence to do it? So here is what I always say. I think choose a slice of a subject and then make it your own. And also it doesn't have to be that you're teaching to people overnight. What you described was in your journey, you did a blog post and then you did a podcast, which is a different way of sharing. And perhaps next you'll do a full back-to-back lecture. It doesn't have to be that overnight you're standing up in front of a stadium. Like you can do this progressively. The other thing is that we often forget that small group teaching is just as valid. So if you're part of a community, just lead your small study group, and also try and write notes for that study group and see what happens there. There's many ways, but yes, you should be teaching. There's no shying away. If you're not teaching, you're also not learning to the full extent, because teaching is the worst form of pressure. Like before you teach, you're so nervous, and it just is the best ingredient for owning your subject, because when you're under that type of pressure to present something, you have to relearn everything. You have to be very good at communicating it. And it's a great forcing function for really mastering your subject. So another reason that newcomers should teach.
That's an amazing nudge. This is one of my pet examples, but just asking why batch norm works has also led to very interesting research results.
Absolutely. It's led to like how many papers at this point, all with contradictory results. I mean, it's very interesting because I think, another thing is residual networks. Like if we think of something like ResNet, the actual impact of having these skip connections and whether that can compensate for batch norm, all this starts with like very basic questions, like why do we do certain things? Like what has become, frankly, another thing is that the other day I was looking at a code base and I realized that someone had been using CFAR normalization numbers for ImageNet. And they've been doing so for a year and a half. And I was
Wow.
like, but this is a code base used by so many people. And it turned out it didn't matter. And it's just so interesting. Like when someone asks you, why are you doing this? Everyone's like, oh, I don't know why I'm doing this. But I think that it's frankly that we don't ask enough. We always think there's a reason. And so we shouldn't ask the question. But the truth is the best questions are ones that are the obvious ones. It's how you start off the show. Asking stupid questions is often the smartest person in the room.
I guess there's also this interesting comment which says great researchers don't go, what does this piece of code do, but they look at a code and they go, why does it do something like this, or why are we using? So just asking that why is also interesting. And if another one of my suggestions, if you're too shy to ask any questions, now is the best time, because I think there are two kinds of people for online meetups. One, the extroverts are the ones with their webcams on, the introverts are the ones with their webcam and audio off, and you can put up an alias and just put your questions in the chat as well. If you're too shy to put yourself out there and ask these questions, pretty much all of the meetups right now are online, so that's an amazing chance to ask questions to even someone like Sara if she's doing a meetup.
I love that. Also, it's almost like this weird rush. Like as soon as you ask a question, even by chat, I bet you're going to ask another question by
Yes.
chat. It's something I try and do in my lessons. Like I try and get people to ask a question early on, because what I've realized is that once people ask a question once, they're much more likely to participate again. It's this odd, you realize it's not as bad as it sounds, and then you're all in.
I've really enjoyed watching your talks. You even try to involve the crowd. It definitely gets a lot more interesting there. I remember watching a few of your talks where you'd ask questions to the crowd and actually ask people to answer a few of your questions. So
I know people are always shocked when I do that. They always think it's a joke at first and no one answers, and I'm like, no, but what do you really think?
that's an interesting thing to learn, I think, for everyone who's doing a talk. I also have this question. You're very connected to your roots, and I guess this is more of a bias that I think we all, especially in the machine learning world, grow up with, which is San Francisco. The Bay Area is where the smartest people are. That's where the main AI culture is, or any tech culture is. Did you have any perspective change? Because I know you're very connected to the roots. Once you moved to the Bay Area, did you have any perspective changes about uh, how the culture is there versus back to your roots?
Oh, I guess that's a few questions there. So, as I mentioned, I grew up in various countries in Africa. I guess most of my childhood was in Mozambique. And part of your question is, were there any cultural differences in San Francisco? And I guess part of that is related to machine learning, perhaps, and part of it's more broad. Um, I think that there's definitely a tricky part of culture in San Francisco where things are thought to be solved. And that means that there's a tendency to see problems as we have a great set of tools and we have the brightest people around, so let's just solve problems. And frankly, that's just incorrect. like anyone who has been elsewhere in the world will see that sometimes this tendency to want to go solve things goes horribly wrong. And in fact, I think that it's tricky because programming is such a beautiful art form in so many ways, that it's so crisp and so self-contained. And so it feels so pure that you can arrive at these beautiful sandbox solutions. And I think what engineers have to remind themselves is that everything looks beautiful in a sandbox. It's when you leave your sandbox and try and introduce a technology to the world, it has to work with what humanity needs it for. And I think that's where San Francisco and wider Silicon Valley culture has really failed. It's that there's a tendency to launch products for what is seen in the US and then just deploy them to the rest of the world. And what I would suggest is what has been some of the most exciting tech that has emerged is companies which have grown in their own economy to a huge size and all of a sudden Silicon Valley is like, wow, I didn't know this company existed. But it's very obvious to the rest of the world why that company exists, because they're fulfilling a need that was a gap of how technology produced doesn't meet how communities use that technology. And I think that became very clear to me in Africa, because there was many examples of technology that was simply deployed, but didn't really fit how people were using that technology. I mean, I remember I was in Ghana last year for the first half of the year. I was helping set up our new Google AI lab, and I would try and like call an Uber, and the Uber would just be on my screen but never show up. And it was so interesting. This happened like 8 times. And I just kept on thinking, it's so bizarre. It wouldn't cancel on me, but it wouldn't show up to pick me up. And what I eventually realized is that one of the Uber drivers finally was kind enough to message me and tell me why. And it was because I was using credit cards. And the Uber drivers there don't want to deal with credit cards because they have to go drive to the Uber head office. They lose a day. They then don't get cash, which they want because they don't want to go a day without having income. But the other fascinating thing is that Ghanaian culture is very, very non-conflict. It's very conflict adverse. So the other interesting thing about that was that no one told me that it was because of my credit card. And so it's just fascinating because it highlights how technology has to reflect the community, and it has to be built by people within the community. And this is the most interesting thing that I hope that we can make it less about Silicon Valley, because I think partly we're starting to see these exciting tech hubs emerge all over the world, like in Lagos and Nairobi, but also in India, in China. Like, we need to also place conferences there and start rotating more where we meet as a machine learning community, because it's really, it's kind of tricky that for the last 3 years we've been in Canada every year for either NeurIPS or for ICLR or for both, but we haven't yet hosted a major conference in Asia, like in recent memory. And in Africa, this would have been the first year, but unfortunately it wasn't possible. And so rotating where we have researchers connect, I think, is one of the first things that we have to do, because partly this issue is why Silicon Valley thinks it can just take the sandbox and export it, is because we're not leaving the sandbox. And so I think that's really important. Same for, perhaps researchers that are working in India, that there should be exchange programs where we can have much more fruitful conversations about what technology is working and how it's interacting.
I form my questions like a very badly trained neural net, which is why I sort of mix a lot of questions. But I definitely agree with your points, especially in India. That's still the case. You absolutely wouldn't get a cab, at least in small cities, cities that aren't the main hubs, like my hometown. If you put your credit card in there, you're not getting a cab. That's for sure.
Yeah.
But I remember another one of the points that you had mentioned in one of your talks is data is expensive, which also causes which had caused a few issues for you while trying to get a cab. For me, just to point out to the audience, I pay almost 1/3, sometimes half, as much of my rent to get a good enough connection. I'm still absolutely terrified about it. I have like 2-3 dongle backups just in case that also fails. Do you think such constraint problems also bring interesting contributions to result? Because many people in the US don't realize that this is also a problem, like you mentioned.
Yeah, absolutely. I think it can be an odd, I guess in American lingo, it would be called the underdog benefit. So having constraints actually can sometimes spur innovation. So the same way that often when there's a constraint on compute, we think more carefully about how we use the compute. I was really amazed to see that one of your research projects that helped culminate in the AI residency, you ran on a single GPU. This is the type of work that we need. We need to have research which is not only done on large distributed compute, but we need often the most interesting research and most fascinating approaches are driven by necessity, and not necessarily by the ability to sprawl out thousands of jobs. Instead, it's because you've had to do interesting tricks to make something work. And so I think it can absolutely be a benefit. I also hope that it's not a permanent state. Like, I hope that one of the things that I think is the most important thing to democratize access to machine learning is actually compute. I really think that universities across the world should be supported with high levels of compute so that students can benefit and are able to actually run experiments that are interesting and that are not, some of my students in Nigeria are running experiments in Colab notebooks, which is great, but if you're trying to train an entire model in a Colab notebook, it's miserable. And you're trying to time that so it doesn't coincide with a electricity blackout, which is actually quite common in Lagos because there's frequent electricity outages. So if you're in that situation and you're trying to save your checkpoints so that you can actually load something and keep on training, it's incredibly painful, and we need to do better at how we solve that. At least for university students, we can start there. But figuring out how we can create resources so that people are not at least able to make progress on problems that they choose, it's important.
I guess many people don't even realize I'm sort of continuing my complaints about the
I
generic
like
statement.
this. I like this.
But many people don't realize. So my box, the single GPU that I have would have costed around $2,500 in the US. It costs $4,000 in India, and that's not a huge difference, perhaps, but that's equivalent to half a year's salary, even more than that for many people in India. That's 10 times the monthly rent for many people. So I think people really value these things a lot more if they don't have easy access to them.
Absolutely. I mean, what you're talking about is something which is very, very prevalent all across Africa as well, which is export control. Import and export controls means there's heavy tax levied on electronic imports, which make things like hardware extremely prohibitively expensive, but also things like laptops or, other types of electronics. So figuring out I think it's all part of the same problem. Like, if we talk about democratizing machine learning, it's not just the education, but it's also the tools. And so those have to go hand in hand.
Absolutely. Coming back to your journey, I know you've spent a lot of efforts outside of FastAI. FastAI wasn't the single dot connecting your journey, but I'd like to know if at all FastAI was helpful in any way, and if you have any advices for your junior classmates, if I may, that are about to start the course.
So FastAI, I think, was fantastic, and I'll say why. FastAI was the first program, and I was part of the first ever in-person cohort. So I was in the very first class that Jeremy and Rachel ever held in San Francisco. And I think it was incredible because, firstly, it was a knowledge which had previously been only part of labs and not being documented. And so all the tricks and the tips that they had about how to train deep neural networks were previously not documented. It's not like you could go and buy that in a bookstore. It's not like you could, there was a thread on the internet. These were things which were in labs, but also a lot of the community wasn't particularly interested in documenting it. I mean, I think Ian Goodfellow's deep learning textbook came out later the same year. Perhaps I think it was like later the same year that they started the thing, but his textbook even was about the theory of deep neural networks, but it didn't touch on how to get started. And that was the other very interesting thing that was novel about their approach, which is, I think what Jeremy and Rachel realized is that there was a huge gap between the books about the theory and how to actually make it feel more possible that you could just start, that this wasn't a mystery, that you could just literally run lines of code and implement these ideas. And so that was actually revolutionary at the time, the same way that the AI residency is. These things came around the same time, and they were both about access in completely new ways. And for me personally, I think the program, I thought it was fantastic. I thought both the ability to connect the theory to the code, as well as like I met really good friends in that course, like people who are still very close to me, like Melissa Fabros, Tiffany Williams. They were all part of that first cohort, and they're people who I've stayed very close to since. And I think that community aspect was very, very important to me because I've been studying by myself for so long. What I will say is this: I think that when you go into a course, particularly now it's online, you should be more specific about what you want to get out of it. Online learning is more difficult by nature because in some ways you're not in a classroom, so there's not the same level of social accountability. So definitely go through all the notebooks, but think about how would you adapt it to your problem. I think it's when you try and connect it to what do you want to do with this curriculum, how do you want to adapt it to the particular problem you're solving, that's when you really start to understand the material. Because it's very possible to go through everything and not concretely get a grasp what's happening. And it's important to kind of set yourself the challenge of how would I adapt this? How am I going to take this and make it my own? And I think that Jeremy and Rachel really encourage that. They've profiled a lot of work from students over the years, and they've really put the emphasis on like celebrating their students, which is really incredible.
I mentioned this on almost every single one of the Fast A interviews, and I'll continue doing that. But Jeremy, in some of his lectures, really showcases, and I think it's also he shows his fear of math and research, which is where he walks us through. Hey, this is how some theory looks like in mathy jargon, which is not to disrespect any research work or otherwise, but and then he shows us the code in parallel, which really makes us less intimidated, which we would be otherwise.
Yeah, I mean, he's very, yeah, he knows what he's doing, and he's not trying to be a NeurIPS author. He's trying to tell you that you can get started today. And that is often as important as equipping someone to write a paper, because you know what? Not everyone has to write a NeurIPS paper, but it's really important that we empower a lot more people to run a deep neural network. So I think that's huge. I think it's important with the caveat that we realize that the journey is not over once you've done fast.ai.
Absolutely.
Fast.ai is exciting because it's very, you get started immediately, but a lot of the theory, I think that you go over in that course, it's very coder-centered, and it teaches you the implementation tricks. And so I think it's a great starting point to dive into more of the theory that really backs some of the architecture developments that they profile. Yeah, I don't know how you found your experience when you prepared for the AI residency interview. How did you prepare?
I don't want to share it because I am sure other people would end up failing through that. But
Oh.
I did a lot of.
I'm certain that's not true. Don't be so hard on yourself. I will tell you something. At that point in the interview process, it's just luck. I'm so certain of it. If you didn't bomb the interviews, everyone there is so talented at that point. And that's what people, I think, especially when you come within Google, you realize it's not this like perfect ranking like of candidates. It's so noisy. And that's why I tell people you must always apply again, because the truth is it's not a rational system. And if you made it to the final rounds, it's because to a large extent you really deserve to be there. So I don't believe it when you say that when you're so grumpy on yourself.
To me, I would still disagree with you, but I don't want to debate on that. To me, I did a lot of I did a lot of competitive programming, which I absolutely skipped. Even though I was a CS undergrad, I was just trying to break the stereotype, more of a stereotype that I was exposed to, which is I was told I can't enter machine learning. So this was around 2015 in my freshman year, because it was supposedly, and this was at the time when TensorFlow wasn't out, so publicly. We were told that, hey, machine learning is more of a master's, PhD oriented subject, which is why I got into it. So I skipped the competitive programming aspect, which I was supposed to do in my undergrad. I did a lot of that. I tried to implement some papers because I thought that might help me understand the nitty gritty details. It's different, I think, when someone walks you through it in a lecture and when you're out by yourself just trying to implement it, because there's no supporting material. there are no documentations. You need to piece together everything.
I always think I'm slightly hesitant to recommend that people implement papers, mainly because I think I'm slightly skeptical that the quality of how people describe methodology in papers is good enough. I think that often people, and I think that's changing because of things like the NeurIPS reproducibility challenge, which is excellent, which kind of has entire teams aiming to reproduce papers, and it puts more pressure on researchers to provide adequate description. But often I think that, it's interesting. I was literally just talking to Stephen Merity, a few weeks ago.
On
And
your
he's
podcast?
on my podcast. Yeah. And he's a very, very well-known person who works in language. And he said he left the field of language. And I said, what? And he said, yes, because I tried to implement a paper and I just couldn't. And I just couldn't, and it frustrated me so much. And it turned out it was a combination of issues with the code, with the equipment that they used. They used a large-scale infrastructure setup, and it so disillusioned him that he left the field. And he came back a year later. And that, for me, is like a great example of a story I've heard from many people who've just tried to replicate papers. So what I always say is, if you do replicate a paper, email the authors. It's very common to actually email the authors to ask them for code. If they haven't open sourced the code, ask them for code for at least part of the paper you're struggling to implement. And I think we should start kind of holding researchers more accountable, because often I don't think it's a very pleasant experience. I think it can be quite frustrating for the person involved.
This is also a machine learning community bias, but I saw a tweet trend the other day which mentioned, hey, I thought writing machine learning code is really hard, and then I realized I was looking at the wrong repositories for a long time.
That's actually so funny. So true, though. It's so sad, but it's so true.
I guess, and I also want to point out, it's not necessary to implement papers. This is more of a directed approach, since this was a research program that I was applying to. So to me, it made sense to practice that. But it's also not a necessary requirement at all for the learners.
Yeah, I do think if the code base, so I guess two things. If the paper has detailed methodology, it shouldn't be an impossible task. And I definitely think it's good to improve understanding. The problem occurs where there's a discrepancy between the vaguely worded paper. But it's definitely one thing that I think can also bring you closer to researchers if you email them. It forms like a relationship where they are aware that you're working on that work.
By the way, we mentioned your podcast. So for the audience, please check out Sarah's podcast, which is called underrated.ml. I think that's a website. Subscribe to that. That's much better than this podcast, at least if you're listening to this.
Not at all. Well, actually, before we got on this podcast, I was so admiring your setup, which is far more professional. So my podcast is with my little brother, Sean. And I would describe it as enthusiast amateur hour. Your setup is far more professional.
That's another thing that I can continue disagreeing on, but I want to talk more about how maybe ask you, how did you prepare for the interview process? Just as a meta advice, I know this doesn't apply to everyone because your journey would be very different to others, but how did you prepare for the AI residency interviews as a proxy to people who are preparing for any such research-oriented interviews?
So I have a few suggestions. One is that I would focus a lot on fundamental machine learning. So I would count on a few things. One is that people ask about your research. So know your research in and out, whether that be applied projects or whether that be previous publications. You will almost certainly be asked at some point during the process about projects that you have done. That aside, there's also a bucket of questions on what I would call fundamental machine learning questions. And those tend to be not about kind of very detailed questions about the latest paper that has come out. They tend to be about the fundamental building blocks of like models. So, for example, what do you speculate batch norm is doing, or what type of distribution would this be if there were essentially like a graphs that look like this? What is the distribution that describes this? What is a form of like statistical confidence? Like, how would you think about that? And these are really the questions that are not about the latest and greatest that's come out, but more, I would suggest reading like the introductory chapters of my favorite two books. I had to say to this day, A Deep Learning by Ian Goodfellow, Aaron Corville, Yoshua Bengio. I believe those are three authors of that book. And then Elements Statistical Learning. I think those both give you a really grounded foundation and these kind of basic questions. Linear regression, know your linear regression inside and out, like because these are the models where researchers like to center questions because they illustrate some of the core fundamentals of machine learning. The third bucket, of course, is coding, and there I would again be strategic about what you focus time on. Most likely the questions will be relevant in some way to what you would see in a machine learning setting. So I think it's less likely that you'll get some complicated hashing problem where you have to configure or optimize some database storage. It's much more likely that you're going to get a core algorithms problem or have to implement an algorithm in some way or get a standard kind of I guess one of your standard types of I guess in some ways, like I would either anticipate that you're expected to implement an algorithm in some way, or that you're expected to do a standard optimization problem where you have to go through and showcase a knowledge of type and a knowledge of optimization speed. Yeah. How was your coding section? I imagine that your competitive programming was an advantage there.
I wonder who hated me so much to give me a recursive dynamic programming problem.
Oh!
I'm just kidding. I'm just trying to scare the audience.
Okay. I was like, wow, that's intriguing.
I wonder how much I'm still allowed to say because I'm still very scared of NDAs that I have signed. I wonder if anyone
I
actually
wouldn't be
reads them.
specific. Yeah. No, I think you should please do adhere to your NDA. No. I mean, I say all this mainly to equip people for what they should focus on. It is also very possible, because of the nature of how interviews are done, that you get a completely different experience.
Absolutely.
And that's the interesting part about this. But the things that are within your control are definitely how you speak about your research. So please get that right, because how you speak about your research is a big part of programs like this, because it showcases your passion and how you want to grow and your knowledge of your own research agenda. Having a research agenda, having an idea about why you do research, what questions excite you, what makes you curious about the world, those are all things that are within your control and you can speak to. And so figuring that out before, and this is not specific to Google, because I actually think there's many possible finish lines that are equally as good as Google, but any research interview, know what you have done inside and out. And if someone asks you why you made a certain decision in your algorithm, be able to speak to that. Also, here's another thing that I will say is that it's really, really important for coding interviews. Don't import SciPy, or don't import an algorithm when you're asked to code an algorithm. Presume that the intent is to showcase your knowledge of that algorithm. Yeah.
I skipped your answering your question, but just to reiterate, I was just trying to scare the audience. I didn't get such a difficult question. It was helpful, I guess, and this applies to research as well, like you mentioned, but it's more defined for competitive programming since we've been doing this for so long compared to research interviews, I guess, if I have to put it like that. It's easier to connect the question to something you've done earlier. So it's like reading a math textbook and actually knowing what you're talking about. It's like just looking at the end of the chapter exercise after just reading the theory. If you've been doing that for a long time, if I can connect it like that, if I can put it like that. So if I was getting any questions, since I had been practicing it for so long, it was easier for me to in my head figure out a mind map and actually solve the problem. So to some extent it's helpful.
So this is getting at a really important point, which is that for better or for worse. And frankly, I think it's a little bit tricky because so all these coding interviews have, to some degree, if you do enough of them, you start recognizing the patterns. And there's a finite amount of patterns, right? It's really hard to, introduce brand new patterns every single week. I think that's often a bad thing because it means that candidates who just have a far more time become much better. But I also think that the best way to equalize that is just to let people know that and to encourage them to use resources. It is like you're describing, as if you see all these coding problems tend to reduce to a finite number of patterns, and if you again and again repeat it, it starts to feel like, oh, I've seen a variation of the story before, and then you just have to try and identify the twist. And that's, again, I don't know how I feel about that. I think that tends to exclude a lot of talent from the field because they just either were not told early enough to do that, like that if you kind of do enough of these variations, you'll start to see the trick, or they just don't have enough time because they have other commitments. So it's difficult. I'm also no longer as sure that these type of coding questions measure true ability, unfortunately. Because I feel like I've seen enough variance in performance on coding interviews to know that it just isn't a good discriminator in terms of talent, particularly for research, because research is very different from pure engineering. And so I hope increasingly we'll move towards a coding test format, which is more conducive to actually testing research knowledge.
I was still in university back then, so I was still trying to pattern match and reverse engineer how interviews are done, which is why I was just trying to pick on how can I get through this. But I absolutely agree with you. What happens? This is also many people a question that many people would love to know about. What happens once you get to the other side? What does a day in your life? And my favorite twist to that question is, what does a day in your life on non-pandemic days look like? What problems are you working on?
So when you're working on research, you tend to work with other collaborators, and that tends to be centered around a project that you're interested in. So a lot of my research interests on how do we train machine learning models that fulfill multiple criteria. So they're not just high performance test accuracy, but they're also compact, robust, interpretable, fair. And this is actually a really interesting area because until very recently in computer science history, we've been focused on test accuracy. All we've been trying to do is get models trained that will deliver a level of performance that's comparable to human level performance. And now we've achieved that in several domains. But at the same time, we've realized that test accuracy doesn't capture often what we mean by good performance. Like these models end up being very brittle, especially in the real world. They've shown like kind of odd points of failure. And so a lot of my work has been on how do we create tools that allow people to identify points of failure, and how do we train models that are robust, that can be deployed in the real world and not show these kind of vulnerabilities to distribution shift, to adversary examples, but also that provide feedback loops to humans so are interpretable. And it's really interesting work because in many ways it's about measuring progress in different ways and comparing how we measure progress according to top-line metrics to other measures.
All of the things you mentioned could become a different interviews in themselves. But I want to focus on one particular aspect of your research interest, which is model compression. Why do you find it interesting? If I ask that.
Oh, yes. So model compression is interesting for both theoretical and practical reasons. So firstly, what is model compression? Model compression is really about, in some ways it's as poorly defined, but it can mean a few things. It can mean reducing the number of weights in a model. It can be reducing the representation size, so changing from float 32 to float 16. But the overall goal is to make the model more compact. And the reason why that's interesting theoretically is that it's kind of fascinating why we need so many parameters to begin with. A bigger is better race has dominated the world of machine learning. Like, in fact, we've just been doubling network sizes every year. And it's puzzling because it's not clear what all these extra parameters are getting us. For example, if you take Inception v3 and Exception v4, they actually have double the number of parameters. So Inception v4 has 40 million parameters, Inception v3 has 20 million parameters. So you've doubled the number of parameters, but the test set accuracy only goes up by 2%. So it literally is really interesting because it makes you think, why is that just diminishing return to parameters? The second aspect is all these parameters are very highly correlated. And so you can actually predict the value of 95% of the weights using just a small holdout. And the third is that you can actually remove all these weights after training. So you can remove 90% of all weights and still have a useful representation with a comparable end test set accuracy. So what all this suggests is that test set accuracy is not sensitive enough to measure what all these weights are actually doing. What is changing about the behavior as we end up with radically different networks? And theoretically, that's why compression is interesting, because compression is really asking, what is the minimal sufficient representation that can map this function in a useful way? And why? Why can we do it with far less? And that gets to information theory. It gets to really the properties of Occam's razor, which is that simplest is better. If we can do it with a smaller network, why do we need a large network to start with? But then there's the practical reasons, and the practical reasons are equally exciting. It's that right now, most parts of the world are resource constrained. We talked about this earlier. You talked about having your extra backup, a kind of internet credit just in case things go bad. I mean, this is the reality of most of the world. These are the communities that I grew up in. Often people are not even on smartphones. They're pre-smartphone. Yeah. Most technology, frankly, is going not to the computer, but when people make technological progress, they're making it to a smartphone. So when we think about making technology accessible, we have to think about how to make it accessible within resource-constrained environments. And this is a huge motivator for me, because I think that the more that we can do to actually make neural networks more compact, less memory, and less latency, so faster inference, the better at making sure that this technology is actually used in a sensible way.
Try for the audience, try telling your manager, hey boss, we can double the parameter size, that'll triple our cost, but it'll give us a 2% increase in accuracy, and let us know how that meeting goes.
That's so funny. It's so true. That conversation would only work at a big industrial lab.
I don't want to point out the people, but I wonder, I spent a lot of time on Twitter. I waste a lot of time on Twitter. I tweet every 30 seconds, but there was this interesting pointer where someone pointed out that one of the very famous recent papers actually used 9 minutes worth of energy, of how much energy is produced in a nuclear reactor to train the model.
And this is increasingly becoming the invisible cost. So this is another reason, is that there's almost two separate use cases for compression. One is training cost, which is becoming enormous, and the other is inference cost, which is much more about how we make this work for the world. But both are becoming enormous, especially if we think about what is the goal of machine learning research. A lot of these simulation-based or huge data set-based approaches are essentially relying on increasing the size of the model, increasing the size of the data set, or increasing the amount of simulation in order to make progress towards a human level. And if you think about the performance of these models versus, let's think about our own hardware, which is the human brain. The human brain is interesting because it's both, oops, let me just get my screen back. Okay, I'm back. Lovely. The human brain is interesting because our hardware is both, we think of our hardware as both the hardware and the algorithm at the same time. Whenever we think of our intelligence, we think of the hardware, which is our brain. And what's interesting about it is that our brain is in fact very efficient. Like if we were to try and scale the approaches that we're using in a hardware setting in terms of the number of parameters, it seems clear to me that we are going to either be using massive amounts of compute far beyond our current scale, or this approach is just not sustainable. And we need a different way of thinking about this problem. Rather than just throwing weights at the situation, we have to understand what these weights are doing. And we have to use our architectures in a more useful way. Because we're so far from human level performance on these tasks, and our solution seems to be just throwing more data and more weights at it rather than thinking about the formulation of the problem itself. And there has to be a cliff there. I'm not sure what the cliff is, but it seems like it has an expiration date.
We need more practical approaches like this to answer that. I would like to discuss one of your recent works as a proxy to understanding also research approaches, but since it's also connected to this one, which is titled for the audience if you'd want to look it up, Selective Brain Damage, Measuring the Disparate Impact of Model Compression. If you could share a brief overview about it, because I know the paper has been out and the audience can look it up if they'd like to.
So that's interesting because that connects compression to interpretability. And in fact, that's an interesting connection because there what we do is we ask, how do compressed model behavior differ from non-compressed? And what we're really saying is, let's surface a subset of examples where the performance differs. And what we find is that compressed models differ most on atypical or noisy examples. So examples that are already challenging for the model. So it seems like all this extra capacity is needed to encode the long tail of the data representation. What's the long tail mean? It means those low frequency examples. So let's say that you had a data set full of dogs and you only had like 2% cats in your training sample. A compressed model is less able to detect the cats. And what that suggests to me is that we need to think about the strategy for the long term in order to use our capacity better. If all this extra capacity, so doubling the weights to get 2% accuracy, if that doubling of weights is just used for these rare atypical examples, maybe we can just do something better in the pre-processing to handle those examples. Why do we need to throw double the weights at it? And so it's a really interesting direction of research that looks at how we can just treat the data where these diverge the most in a different way in the hope of actually avoiding using all this extra capacity.
Broadly speaking, and this podcast is actually just a way of understanding how things happen at different institutes. But how do you find these ideas or these research projects, these tangents to explore?
So I think a lot of that is that I've chosen to work in different areas, which I would suggest to people, particularly at the beginning of their career. So you want to become a domain expert in your particular area. So definitely first establish yourself in one area. But I decided that I wanted to work in both interpretability and model compression. And now I'm doing, collaborations across even robustness. And I found that it's led to connections that I wouldn't have had otherwise, because often you see things that other people can't because you've thought about the question in a different way. And I would definitely suggest that it's important, that often it doesn't pay off immediately. The people who specialize in one career tend to end up with more publications early on because there's this nice kind of short-term effect of you're able to just get work out quicker. You're an expert, you've chosen one domain, and you just end up, you can even tweak an idea and end up with several publications. And jumping between subfields has its own cost. You tend to not have as quick an iteration cycle between ideas, but in the long term, over the course of your research career, it's more productive. And it pays off more because you see ideas or connections that perhaps others don't.
I guess it's also like you mentioned, if you try to connect different ideas together, for example, quoting your example, model compression is counterintuitive to interpretability, so it makes approaching problems difficult. But if you try to group them together of sorts, it's also an interesting tangent to explore, I believe.
Yeah, it's exciting. And I think it opens up a whole new area of by controlling the compression, you actually have different snapshots of the model, and it allows you to really control in a precise way, how can we identify what's different and then surface that to a human? So making those connections, I think it's helpful just to dabble. You know, some of my colleagues do this in different ways. Some of them go to conferences that are outside of their comfort zone. So instead of just going to NeurIPS, which is the main conference for researchers, they'll go to, actually I've forgotten the name. It's very cognitive science heavy conference. So it's an oddball conference. I don't know if they would like me describing it this way. So maybe it's good I don't remember the name, but they'll go there not because they think it will result in a paper, not because their colleagues are doing, but they think it will perhaps like inspire them in a totally different way or reset their brain. Sometimes we have to kind of do something very different for our brain to be triggered with a thought or an idea.
Which is what makes us in retrospect go, oh, that's an interesting idea, and that's the reverse engineering to it. That's how people get it. For people outside of research, I guess, in my opinion, Kaggle competitions become very interesting here because they allow you to explore very, very, very different problems just in a matter of 3 months, which of course is nothing if you want to be an expert in that, but is interesting enough to give you a taste of that domain or that tangent.
Yes, and also competition is a great incentive structure. I mean, I'm a big fan of incentive structures because I think particularly for people who are self-structured, pursuing their goals on their own, you want to have goals, and Kaggle offers a way for you to have an intermediate objective to improve your skills. So again, I'm a huge fan of Kaggle. I haven't participated, but I've seen many people who have participated and had amazing experiences. And I think, again, that's a good thing because we want to be able to measure progress, particularly when you're driving yourself and you're self-motivated. You need some way to be able to see all my effort is translating into something. And that's why I think Kaggle is a great resource.
I think this is a question from the AMA, and I think they're Kaggle. I'm not too sure, but it's by Madao Neat from Twitter. They're asking how important is it to know and understand math or stats when you're trying to write a research paper or when you're trying to understand machine learning?
Oh, so that's a good question that has perhaps a mixed response. So yes, I think it is important to understand math. At least you want to understand foundational mathematics, and I think it's easier for you to articulate your ideas sometimes if you have a strong anchoring in mathematics. That being said, some of the biggest breakthroughs in machine learning have had nothing to do with an understanding of mathematics. Like, I mean, we described batch norm. So batch norm, the paper has math in it, but the author, I think, would admit, or at least from my understanding, is very candid that he discovered it by accident. He was just doing different experiment setups and discovered it worked, and the paper almost retroactively tried to explain what they noticed empirically.
And it has a lot of math for people who haven't read the paper.
Yeah, but it came after the finding. It wasn't like the math prompted the finding, which is fascinating. And I think there's so many papers like that where the empirical finding came first, and then there was almost this window dressing that was put to explain it. And I think it's good to be honest about that because I think it's something that makes me quite grumpy about the machine learning field, which is people feel the need to do this extensive window dressing to, like, you know, explain what they discovered empirically. There's a huge strength to empirical research right now, and there's super exciting breakthroughs which are happening because of empirical, well-grounded experiment setups. And I think there's a place for both. I think there's more respect increasingly for empirical papers. So I was chatting about this with Jonathan Frankel the other day. He's a researcher who published the lottery ticket. So that's an example of an empirical paper. He started with just a hypothesis. It wasn't a proof, it was a hypothesis. And then he demonstrated that empirically, he showed some interesting patterns that aligned with his hypothesis. And I think that the fact that there's more and more researchers like that who are being published, I count myself as an empirical researcher. Like, a lot of my papers are driven by a hypothesis that I want to show empirically, disprove, or hold. And it's important. There's a role for both in this field. And so if you are stopping yourself from entering into the field of machine learning because you're scared you can't do math, I would dip your toe in, and I would say I would get a feel and remember that there's plenty of areas within the machine learning field.
Yeah.
Research is a particularly odd sub-community, right? Because the goal is to produce papers, to push forward the frontier of knowledge. But there's many applied problems that equally need treatment, and there it's even less important that you are able to I guess, depending on your comfort with math. That being said, I would say that a comfort with mathematics is just exciting because it unlocks
Yeah.
a lot of the beauty of these papers. And also, it allows you to communicate in a really compact and straightforward way about some of your ideas.
With the disclaimer that I'm much more involved in the content, whatever that means. To me personally, math has never been the bottleneck. Maybe that's because of the Indian education system's emphasis on math, but it's always for me been code and being able to just translate an idea, a machine learning idea, maybe a Kaggle competition idea into code. So I think that for me at least, that's a bias I think takes priority.
Yeah, I mean, absolutely. I think if I already had like a strong understanding of mathematics from my economics background and econometrics. And I think for me, if I think about my journey and the bottleneck, it was definitely the engineering, and it was also the theory, like understanding the theory and mastering it. But in terms of the brute force moment, it was becoming an end-to-end technical person. So also remember that you are part of a team for a reason, right?
Yeah.
So when I collaborate with my coworkers, we tend to augment each other's skills.
Hmm.
And there tends to be people who bring different things. For example, I have a coworker who doesn't like to write. Like, he likes to primarily code. I like to code, but I also like to shape the writing. I have another coworker who primarily likes to write proofs. That makes them very happy. And so the biggest, I would say, misconception I see in people who are entering is this fear that you're meant to be everything. Jeffrey Hinton, an AMA thread a few years ago, I think like probably 3.5, maybe 4 years ago, he did an AMA thread and he said he wasn't very good at mathematics. And that actually relaxed me so much. Because
His level of math would be very different from at least what I would perceive being good at math, although I would
yeah,
argue.
perhaps he's just being very modest. But I think that, again, he's talking about his relative skill sets. And what I've noticed about most of my colleagues is that no one is a winner-winner. Like, I think many of my colleagues who are physicists are not as, skilled at coding. They're more good at theory. Everyone tends to excel in one bucket. The goal is that you should be comfortable in enough buckets, but you should excel in one. And the buckets are theory, math, creativity, proposing your own ideas. And, I think that your goal ultimately is that you need to excel in one because you need to contribute in a way that you're known for in one. But you don't have to excel in each because frankly, it's impossible. It's like the mystery person. There's no such person.
Absolutely. Sarah, I know I can throw any technical, any machine learning related question to you, and you'll share many amazing insights. But for my heroes, for the final question, I like to usually find a tricky one. I discovered you're a painter, so my final question, and I hope it's a tricky one for you, is what would be a favorite painting that you've created, and I'll maybe try to link it in the show notes so that the audience can also enjoy.
Ooh. I did. So I like to gift my paintings. So I actually, it's interesting. So I like to paint, and this is a little bit of a controversial theme, but I like to paint the spirit animals of the people I know.
Okay.
So, for example, one of my colleagues last year, he's quite grumpy. So I painted him like a porcupine. Um, Sam Smith, he's lovely. He's in the UK now. He's a DeepMind. But one of my favorite paintings is actually of my sister. So I'll send that through. But it's a painting of, uh, it's a, what is the name of the animal? But it has these lovely big ears. And it's an Australian animal. And the reason why that was important is that she just moved to Australia.
Okay.
So I did it as a Christmas gift last year, and it's my favorite painting, mainly because she also loved it so much, and it fit her personality because it's a very inquisitive, curious animal.
Looks like I failed at making that question difficult for you. But before we end the call, if you'd like to mention any platforms where the audience can connect with you and keep up to date with what you're up to.
I feel like you've done such a good job of mentioning them all for me. I can't even remember any others, but thank you so much. It's been so lovely chatting, and I find your story so inspiring. So I feel honored to come on your podcast.
It was an honor speaking to you. Thank you for saying yes to my stupid request. Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.